All right, I want to welcome everyone to real-time energy modeling to meet, beat, code, and get the IRA 45L tax credits. Before we get started, I need to say a huge thanks to our platinum sponsor, Rheem. They have heat pump water heaters. These are the future of water heating. They take natural heat out of the air and use it to heat water with zero emissions directly, up to 4,400, can't speak, 400% energy efficiency. Rheem offers a hybrid approach, and so those have backup electric resistance water heaters at 240 volts to ensure hot water all the time. But now they have their new 120 volt system that can quickly replace a gas water heater without the expensive electrical upgrades in most cases. These work by pulling heated air through a filter. It's absorbed by an R410A refrigerant using a compressor to heat the coils that are wrapped around the tanks. And they've got smart technology built in through Ethernet right to your phone, so you can control your heating system levels, sense leak detection, track energy use over time, schedule your time of use programs. And speaking of that, time of use programs are picking up all across the country. So you can imagine these heat pump water heaters function kind of like a battery. That's how I use my Rheem Prestige water heater. I have it heat water to the hottest amount in the middle of the day when rates are low, carbon rates are lower, and energy costs are lower. And then when the peak picks up and carbon is higher and costs are higher, I have it turn itself down and then back up again at night, all automatic through the app. Inflation Reduction Act, we're going to be talking about that. Up to $2,000 tax credit for these Rheem heat pump water heaters, and up to $600 tax credit if you need to improve your electrical system. Go ahead, boost your energy points when you're doing your scenario modeling, and check out everything on these products at Rheem.com, heat pump water heaters. And thanks to our second tier sponsor, Enertech and Water Furnace, with the Inflation Reduction Act, back again, 30% tax credit through 2030 for geothermal energy, one of the most energy efficient products on the planet. As you're doing your scenario modeling that we're going to be talking about, you'll see how that will just drive your energy use and boost your scores by going geothermal, taking that energy right out of the ground, and it can heat water as well. All right, before we get into our session, real-time energy modeling, meet and beat code with IRA 45L. Again, I want to introduce us, Green Home Institute. We're a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. My name's Brett Little. I'm your education manager here. We also have a small team, our program manager, Eliza, who's going to be helping you out with your green building certification, and our executive director, Jose Reyna, who's going to be helping you out with memberships and partnerships. This session, like many sessions, are approved for multiple continuing education units, including our certified green home professional designation under the energy pillar. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Passive House Institute, USCPHC, look for that 5-digit code coming your way. Now, before we get started, it's important to note how what we're going to be talking about today fits into the green building certification programs, and especially the LEED for Homes program. The reality is what we're going to be talking about is a key component to achieving a higher LEED rating for whatever goal you might be doing. Now, before you get there, you need to build your way up. You got to start, again, with the HERS rating. We're going to be talking about getting those HERS rating numbers down, getting improved HERS ratings, which save you and your clients money. And then once you can do that, you can achieve Energy Star certification by getting an improved HERS rating, and then also meeting some other prescriptive items. Once you do that, then you want to start looking at indoor air quality for you and your clients. And then once you've been succeeding at energy and air quality, you can now comply with the DOE's Zero Energy Ready program simply by adding a renewable ready project. And so that's all available for Inflation Reduction Act dollars. We're going to be talking about the Zero Energy Ready program. And then building off of that, you're ready to go with Passive House or one of the green building programs. So the way that it works with LEED under the minimum energy performance pathway under LEED for Homes, anyway, is that you need to achieve that Energy Star version 3. You don't have to get certified to it, but you need to at least achieve all the requirements in the field through the builder checklist and the rater checklist. And part of achieving those requirements is, again, having that HERS index rating of roughly 70. It's different depending on how big the home is and the number of bedrooms, but it's around the HERS index rating of 70, which we're going to talk about how we're going to get there. But we want to get better than that. And so you're going to get a lot more points by driving that HERS index number lower and lower and lower. I can't even fit it all here, but getting it down to 0 under the annual energy use. And you can make up about a quarter to a fifth of your lead points just by getting that number all the way down near 0, which is basically a 0 energy home, a net 0 home, and you name it. So that's what we're going to be talking about and how that fits in, with the LEAD program. And so with that, I'm super excited to hand it off to our speaker today, David with Ecotrope. He's going to be introducing himself and then taking you through the scenario modeling process, and then we'll be getting into your questions. So David, glad you could join us. Welcome. Please take it away.
All right, thanks, Brett. Glad to be here on the webinar here today. Looks like a great audience today. Today, thanks for hosting this, Brett. Thanks, Greenhome Institute, for inviting us over. My name is David. I work at Ecotrope. We're an energy modeling software company. And I'm going to tell you a little bit about Ecotrope, a little bit about 45L, and then also do an analysis of homes that pass 45L to share kind of what the specification for homes that meet that tax credit look like. And then do some scenario modeling to say, let's look at homes that don't quite pass and what types of changes will get them to go from failing to passing that tax credit. And so following that, we'll also do kind of a demo of how we do that analysis to help share kind of what tools are available in Ecotrope to do that analysis, whether you're trying to achieve the tax credit, trying to earn more lead points by driving down the HERS index, or earn Energy Star or DOE or whatever certification, green building certification you're looking for. We also do a question and answer. I'm open to questions throughout. So if you drop them in the Q&A, Brett will handle those, or Eliza will handle those, and we'll handle them in real time as well. So first off, a little bit of an introduction about Ecotrope. So we are an energy modeling tool, but we are kind of building out our platform of tools at the same time. We are a web-based app, so we have access to lots of different data that is been analyzed and calculated in our application for about 300,000 homes every year. And that allows us to give really great insights back to raters about how their homes are performing. It also allows us to kind of close the gap with builders as well. So builders can easily see if they're doing 100% HERS ratings, what their Energy Star compliance rates are like. That way they have that number to say, hey, why aren't I earning this tax credit? Why aren't I doing 100% HERS ratings? And then they can go track down that superintendent or that GC and say, hey, this is our corporate goal, that we do 100% HERS ratings or increase our Energy Star compliance rate. And that can provide that incentive to grow the market by giving them the access. So, because the saying goes, if you're not measuring it, you're not going to improve it. And so this helps them measure that information. We also help provide data to mortgage lenders so they can see and qualify certain mortgages for better rates based on the home performance. We also work with parts manufacturers so they can understand what types of builders, what types of homes will most benefit from their product. And benefit could be, a cheaper home for the same energy performance, or a better energy performance for the same cost, or homes that are just about to earn the tax credit and their product could really get them over the edge. We help them with that as well. And then many of you are aware of our utility work, I'm sure, where we help submit utility rebate program certifications from the app directly to the utility, so you get real-time feedback on your utility rebate compliance. So that's kind of the whole network of initiatives and products and tools that we're working on helping the industry grow. We were really focused on seeing that number of purge ratings grow as much as possible. Right now, there's only about 25 or 30% of all homes, actually it's 30% is the number, so get HERS rated. And that number, we would love to see that grow. And we're trying to figure out ways to make that grow with these tools to provide that incentive structure for builders to continue doing more HERS ratings. So this is a little bit about the data, kind of background of us so far. We do about 300,000 homes per year that are processed through Ecotrope. And a little sneak peek, but we did hit our 1 millionth home rated in Ecotrope recently, and these numbers kind of all add up to mean that we're one of the top providers of the 45L certificates as well. So I'm going to dive into what some of the changes to the 45L tax credit are. And as many of you know, this is a new homes energy efficient tax credit for new home construction. And in the past, this was started in like 2005, I think, and previously, Congress would only ever retroactively renew the tax credit. So they would get to the end of the year and say, oh, that would have been a good tax credit to have. Let's renew it for the past year. And that means it was really hard for any builder to plan on earning this tax credit because they just didn't have the trust in Congress that they would actually follow through and retroactively renew it. So if you don't know that you're going to be paid the incentive, there's no reason to try and plan to get it. It's just kind of gravy at the end if you end up earning it at the end of the day. That's all changed at the first of this year. So late last year, the Inflation Reduction Act was passed, and that extends this 45L tax credit through the next 10 years. So it's now every single builder in the country has this 10-year long runway to say, I'm going to start today and I'm going to start earning more of these from year 0 to year 10. And when they start to look at that number to say how much money or tax rebate they could earn over that 10-year time frame, it's a whole lot of money for a lot of builders. So it's a whole lot of incentive for them to, incrementally work their way towards earning more of the tax credit. So a couple of other changes that happened with the new tax credit is that they changed the way the requirements. Previously, it was a 50% reduction of heating and cooling load, and now it's switched to be based on a certification, which is the Energy Star and DOE Zero Energy Ready Home Certification. This has a lot of benefits. One, those certifications are a little bit more holistic, not quite as holistic as LEED or NGBS, but they're a little bit more than just looking at the heating and cooling loads. Things like California corners, insulated headers and things like that are going to be aren't necessarily perfectly captured in an energy model, but are benefits to the construction of the home. And when they did that, they also added about $500 per home towards the tax credit. So right now, a builder can earn $2,500 per home if they get an Energy Star certification for that home, and up to $5,000 for DOE net zero. There's also an equivalent now for multifamily as well, and multifamily units can earn that same amount of money per unit as long as they use a prevailing wage for all of their consultants. So there's a whole lot more money available for multifamily now as a result in this new tax credit. Fundamentally, it's also so like this based on Energy Star. You have to earn Energy Star before you earn DOE Zero Energy. So it's kind of that layered approach there. And also rehabs can earn the tax credit as well, as long as it's a substantial rehab. There's a few rules around what that means, and there's a lot of interpretation that goes into that. Brett, you have a question?
Well, and you kind of started getting into it. I mean, obviously, this tax credit really is designed, the one we're talking about, for new construction. But, one of the biggest barriers for sustainability is to improve our existing housing stock. So can you just speak to the brief, it sounds like part of the challenge you're saying is on the tax side for the rehab, but then there's also, of course, a technical challenge for renovating a home to this standard, correct?
Yeah, so for the gut rehab, it really is a gut rehab. It's down to the studs. So it's a very substantial rehabilitation of a house. So that doesn't happen all that often, but when it does, those types of projects could earn the tax credit.
Yeah. Now, for those interested in existing homes, I'm posting a link here. Energy.gov, go to making our homes more energy efficient, clean energy tax credits. So there's all sorts of tax credits for existing home improvements on there. Do you know in that there's some money, David, for energy audits? Do you know, it's not much, but do you know if a HERS rating typically complies with that? I think it's the Homes 25C credit. Are you familiar with that?
No, I don't know about that credit.
Yeah, HERS rating is probably going to be more more than you need for something like that. But there are energy modeling tax credits coming out for existing homes. So I just wanted to make sure that everybody knew that and speak to that rehab question. So thank you.
Yeah. The other piece that I want to touch on here, I'm going to go on to this next slide here. So this is kind of a slide about which the requirements are for how much dollar value of the credits for manufactured homes, multifamily homes, and single family homes. And this also means that Energy Star and DOE have control over kind of what the requirements are to earn the tax credit. So we all know Energy Star gets updated periodically, and now those periodic updates are going to impact the 45L tax credit as well. So as that gets cranked down, it gets a little bit harder to earn the tax credit as the years go by. There's also lots of kind of rules, background rules to the tax credit. So the language in the tax law is fairly straightforward. It says earn these certifications. But then there's a lot of definitions about who is an eligible contractor. What does a new construction mean? Does that include gut rehab? As well as what does it mean to sell a home? Because this is all oriented towards eligible contractors can earn the tax credit when they sell the home or lease the home to kind of the other entity. So there's a lot of rules around that. I just saw that the IRS has released the new form which builders use or eligible contractors use to claim the tax credit. It's like the 8908 form or something. Actually, don't quote me on that. It's the 8908. Yes, that was right. And there's a whole kind of in any IRS form like that, there's a whole say, here's how to fill out the form rule set. And there's a whole bunch of rules there about what is an eligible contractor that are super useful. I'm no tax lawyer, so I can't give you too many recommendations about what kind of entities can be the eligible contractor. Tax lawyer would have to be or would have to provide that context. And then there's also additional IRS interpretations of those rules as well that are all available on IRS's website. And from what I can tell, they released the new 8908 form, and they've also rewritten the how to fill out that form and added some addendums to the rules. And that's all things that we've been waiting on for a long time. They've released it recently, so looking forward to diving into that to learn a little bit more about the exact specifics of who eligible contractors are and what the certificate needs are to prove that you've earned the tax credit. All right, any questions, Brett? Yeah.
So you're getting into guts. Great. So, well, on the note for our low income housing friends, and so there's two approaches to low income housing. There's low income housing tax credits, which is very specific. And then there's nonprofit agencies who may or may not deliver those and may just do smaller projects like our good friends at Habitat Humanity, who do all, from my understanding, almost nearly all Energy Star certification. So on the low income housing tax credit side, my understanding is that it's supposed to be more friendly to not get in the way of getting those tax credits. What have you heard or seen out there on that?
Yeah, again, I'm not a tax lawyer, so I don't know exactly
Sure.
what the, how accountants have been claiming those.
Mhm.
I've heard similar things, that it's more friendly.
Mhm.
But, you know, I've never filed an 8908 form, so I can't give real hand, expertise to that.
Yeah, that's fine. I heard it reduced LIHTC basis points. So whatever that means to all of you out there, take that to your tax credit. Now going down to the nonprofits who don't get the big tax credits, but they, want to build better. Have you seen anything out there? There's one question here about being able to shift that tax credit to somebody else or forming an LLC. What have you seen out there like that?
Again, I've heard secondhand that some nonprofits may set up a for-profit entity that is a subsidiary of some kind that the nonprofit owns in order to set up some structure. But again, I can't claim to be a tax lawyer, so I can't claim to say that that's legitimate. But secondhand, I have heard of people doing that.
Yeah. Well, any of you out there who work on this and do good at it, let us know. We'll have you on the show. So thanks.
All right. Let me find my. All right, so I'm going to dive into kind of looking at which homes pass 45L. And what we've done here is we've pulled out a bunch of data out of Ecotrope. And this is data of real homes that have been energy modeled in Ecotrope. This isn't the kind of every home built in the country. We don't have insight on all that. This is just homes that are in Ecotrope. And we pulled out homes that are 0 to 10% above the threshold to pass the 45L. And this is the new 45L, so this is Energy Star version 3.1. And within that band, there's 93,000 homes in our database that are 0 to 10% better than their Energy Star target HERS index. This doesn't mean that they automatically comply with Energy Star, because this is just looking at the HERS index compared to the target. There's obviously all of the other checklists and an HVAC design review checklist that would have to be completed for these homes. Some of them likely did that, but not all of them. So we're able to look at all these homes and see what the specification is and how exactly these homes are built, right?
Do you have a percentage of how many of those are renovations? Are you able to get that from your data?
We could, but I don't know offhand. My guess is that it's very few.
Okay.
Probably less than 10, probably less than 5%.
Okay. But otherwise, just looking at this chunk here, this is what, 30% of the projects you're seeing?
93,000.
Well, I'm just looking at this sort of graph here and assuming that the graph is 100 and the chunk in between it is the ones that are in compliance, is the way I'm seeing it anyway. So maybe I'm looking at it wrong, but.
So the way that we're measuring compliance here is a home has an Energy Star target index to pass. If that target index is 100,
Yeah.
and the home gets a HERS index of 100, it would have a 0% buffer, meaning it is right on. If its HERS index was 99, it would have a 1% buffer because it's 1% better than the target index. If it was a HERS 90, 10%. Does that make sense?
It does. I'm just trying to get a sense for how many homes you're looking at. What percentage are you seeing is passed as far as this way of measuring it this way? So.
Yeah, so this is looking at homes that were rated in the past year, I believe. And of those, 93,000 just passed. This actually may be more than a year's worth of data, maybe 18 months. And so, but we generally see our kind of Energy Star sort of like compliance rate is much lower than this because it's not every home does all the rest of the items.
Sure.
But of these homes, I would say that it looks like it's maybe one standard deviation on that bell curve is 93,000. So like if you want to get all of the homes that are from 0 to 100%, one standard deviation is like 68% or so. Divide 93,000 by that, which you get the total.
That'd be a lot of math. Thanks.
That's eyeballing it. I'm sure math is like, sort of right, but not completely. So we can also look at homes that we're also going to look at homes that are just about to pass. So homes that have a HERS index slightly above the passing threshold for Energy Star. And in that data set where we have about 65,000 homes here. So once we have these two populations of homes, we can do a comparison between the two. We can compare how the homes that passed Energy Star were built compared to the homes that failed to meet Energy Star within this band of 0 to or negative 10% to positive 10% above and below their individual threshold. And so if we look at this, we've broken this out into 3 different categories: the South, Southwest, and North, and highlighted the kind of the key differences that we saw. Now, these are basically just looking at the average specification for homes that failed compared to homes that passed. And there's a few kind of flaws to just looking at an average that I'll talk about in a little bit. But if you look at this, I'm going to stick with the North, and you'll see that the average stud type is a 2x6 for homes that pass compared to 2x4 that fail, which means that the average R value in the cavity is 20 compared to 15. And the continuous installation rates are pretty high. Lots of homes have continuous installation. Otherwise, everything else is the same, but other than the median ACH number. So the median was 3.2 compared to 2.8 there from failing to passing Energy Star version 3.1. I'm going to dive deeper into this North data set to talk a little bit more about kind of more specifically how these homes were built. So like I was saying, there's more than, so like an average obscures some information because you may have things on way either side of the average. And if you're just looking at the average, you're not seeing that variability. And we know that builders really like to trade things off. They don't build the average home. They say, we're going to do really well at cavity insulation or ceiling insulation and do a little bit worse air sealing. Now that's kind of all up to them. That's their preference. That's what they think they do well. That's what they think they can do correctly, maybe. And they all have these different preferences. And raters also have their own preference of kind of how they want to finesse the energy model down to that target and what they're willing to convince the builder to do based on their expertise. So in order to kind of dig a little bit deeper into these specifications, we did a little bit of a cluster analysis of homes that passed Energy Star version 3.1 and clustered them into 5 or 6 different groups. I have 3 different groups on the screen here. And this is kind of like a radar chart where you can see, if you follow the yellow line around, that's group 5, and you can see what the specification is for envelope leakage, continuous R value, and what have you around the radar. And you can see how that differs compared to the blue line and compared to the red line. And that gives you a sense of how these trade-offs are happening. We have another way to look at this that I'm going to go to now. And we kind of have been calling this the Candyland chart because it kind of looks like a Candyland board, I guess. And when we looked at these trade-offs in this cluster analysis, we only looked at these variables. And you can see here, kind of the left is lower performing, the green is to the right is higher performing. And for this particular group of homes that passed Energy Star version 3.1 in northern climates, you can see that they did use 13 SEER AC equipment. They had a 96 AFU gas furnace, R15 cavity R value. And this is interesting because we know that the average for homes that pass 45L is actually R20, but this particular group is actually lower than that. It has a center of more around R15 than closer to R20. Also, no wall continuous insulation in this instance, but they have a really good ACH values of about 2, and the floor to U values of about R33 and ceiling U values of R50. Those numbers are a little goofy because that is the weighted area weighted average of that entire assembly. So it's essentially the U value and a 1 over U to get the R. So the number's a little bit goofy. But that's kind of one pathway to get to Energy Star that more or less will get you there most of the time. Another kind of route that we saw in this cluster was something more like this, where they bumped up the wall cavity insulation, had a little less efficient gas furnace, a little bit worse envelope leakage, and a little bit worse ceiling U value. But this kind of cluster also still got quite a few homes to pass Energy Star. And finally, there's kind of this third iteration. And this kind of just demonstrates that there's always these trade-offs, and homes are very unique. So there's lots of different ways to get there. Looking at an average, or even looking at this cluster, is a kind of guiding post to get you there. Not necessarily like guaranteeing that you will meet Energy Star, but it's a good kind of benchmark to start out at. So the next thing that we can do is we have this tool called scenario modeling, which allows us to quickly iterate over different designs and determine which specification is the best specification to use to achieve a goal. So what I'm going to do here is I'm going to look at all of those homes that almost passed Energy Star version 3.1. And I'm going to say, what if those homes had been modeled to one of these specifications that I just talked about? One of these Candyland chart specifications. And I'm going to analyze that and see what would have happened, how many of those homes would pass Energy Star version 3.1 if they had changed their specification to the spec that we just talked about. So here's the different specs. They're the same thing right off the home, right off the previous slides. And you can see kind of how the distribution of these clusters for the homes built in the north. Each of these specs are about 23 to 24% of all of the homes that passed 45L in the north climates. So if I applied those specifications to homes that failed 45L, we get between 77 and 92% of them across the finish line to passing 45L. So that shows kind of how those specifications are pretty accurate. They do a pretty good job of being a rule of thumb of this is the way to do it for northern climates, and also earned a whole bucket load of tax credits for builders. Some of the changes are fairly big. Particularly are going to 2x6 walls if they already are currently a 2x4. And some of those ACH numbers they're low and not unreasonably low, actually. They're pretty achievable there. So we also tested what happens if for those homes that just almost passed 45L, they would have made just one change, what the impact would be. And you see like one ACH, it gets a whole lot of homes across the finish line. High efficient air source heat pump gets even more across the finish line. And a U value similar to a 2x6 with R21 or an R13 plus R5 also gets 27,000 homes across the finish line, earning Energy Star version 3.1. So we can do all these tests to kind of understand what best changes to promote or what best changes raters could be suggesting to their builders. Any questions with that? What I want to do next is kind of go in and show you how we actually did this analysis.
Yeah, so there were a lot of questions about the air source heat pump, and because it clear you were just sort of using the path of least resistance in the conversation, and then, but to be sure, it looked like those air source heat pumps at the end were one of the things that pushed the most homes over. What about the water heating side? I mean, you have, of course, all these trade-offs in natural draft, which is certainly not allowed, to my knowledge, in the Indoor Air Plus program, which gets you DOE's Energy Ready, or sealed combustion or heat pump water heater. Do you have any clues on that at all?
Yeah, so heat pump water heaters do push a lot of homes across the threshold. And there's also heat pump water heaters will also earn a lot of utility rebate dollars as well, because electricity utilities are really thrilled about being able to get people to switch from natural gas to heat pump water heater to electric. So there's a lot of benefit there as well. We just didn't run it in that scenario.
Sure. Yeah. Thanks.
So I want to kind of show you how we did this. And Brett, I guess could you confirm that you can see Ecotrope app?
I see it.
Cool. All right. So I'm going to show you kind of the tool that we use to do this. This tool is called scenario modeling, and it allows you to specify a whole bunch of different design changes, group them into a specification or a group, and apply them to an energy model and ask how does that change Energy Star compliance, the HERS index score, or what have you. So I'm actually going to kind of walk through this. This is kind of how you define the design changes. And what we did with this analysis is we picked a whole bunch of energy models. In this case, I've just picked 12 here to analyze, but you can analyze up to 1,000 at a time. And then you need to create some design changes. So for infiltration, I'm just going to say what happens if we do 2ACH50. And then you can go through here and add in more design changes. So for one example, we can say R15 with R5 continuous installation. And you can go through here and say mechanical equipment. And let's say we want to switch from furnace to air source heat pump and do a coefficient of performance or whatever value we want to use here. I'm going to do HSPF of 14 or so. Actually, and we're going to just leave everything else the same. Heat pump system type is a split system connected to forced air. And we can go through here and start defining all sorts of different design changes. I'm going to do ceiling roof, R40 bats, and you can just add in up to 15 different changes at once to measure each individual change to that specification. So we use this tool to do that analysis that I just showed you, but a lot of people use this for doing that same analysis, but for a specific builder who is their client to help them earn more tax credit or earn the certification or meet energy code, or simply for a builder that calls up and says, hey, I can't get this particular product, so I'm switching to this one. What's going to happen to my energy code compliance? So instead of having to kind of say, yeah, it does this to this energy model, but we didn't check the other energy models, so you just go check all the energy models and tell the builder immediately. So I'm going to just do one more infiltration change here, just to have a few different options here. And following that, I'm going to go to scenarios. Oops, gotta add a name. One. And the scenarios are kind of the specification or how you want this group together. So the first one, you may say, let's do all of them together so I can see what the cumulative impact is. And then finally, you may also want to see kind of what each individual impact will be on these 12 energy models. So you can do this. This scenario one, though, we have an extra kind of hanging infiltration change. So I'm going to copy it and switch that infiltration change for that infiltration change, and we're good to go. Some other things that people have done is, made an infiltration change that is from like 5 ACH down to 1 ACH at like half ACH 50 increments to see how tight the home has to get until it crosses the threshold. So they can do that relatively quickly in here as well. So next, we have our results. We want to analyze this for the impact on her score, Energy Star version 3.1, maybe DOE zero energy. We have the 45L tax credit here. This is actually the old 45L tax credit, not the new one. And we also have a few state codes that we're adding in here as people request, as well as a few utility rebate programs.
David, can then you just clarify that the DOE zero energy ready that you are checking is then the replacement for the 45L tax credit, and I guess will that be updated just to make that clear?
Yeah, so this like Energy Star version 3.1 and DOE is the new tax credit.
So you got to meet both of them, kind of. Yeah.
If you want to earn $5,000 per home, you need to meet both of them. If you want to earn $2,500 per home, you just need to meet Energy Star version 3.1.
Sure. Thank you.
Yep. So once you kind of pick this, there's a little summary here of how all the scenarios that you're running, and you can press finish, and it's going to process through all these energy models. What it's doing is it pulls up an energy model, it applies a scenario to it, calculates the results, and then removes the scenario and then goes on to the next one. It does that over and over and over again for you, and then emails you a report of exactly how the results are, so you can have a spreadsheet and do all the analysis that you need in Excel, and a tool you're familiar with.
Yeah, well, that kind of answers, the next question to some extent. Well, I was thinking, what about actual energy use and energy cost? If somebody just wants to look at that as well, is there an ability to do that within this, or port it into your HERS rating tool, or how does that work?
Yeah, so that is one of the number one requests for the evaluation metrics is utility cost and energy use, and it's going to be added in the next 3 or 4 weeks, I believe. So you'll be able to, if you're doing a utility allocation or utility calculation for renters, like you can do that as well.
Okay. Now I can envision someone wanting to go, well, how much does all this stuff cost? Which of course, nobody ever wants to answer that question in this job, right? But it sounds like you can download it to an Excel and then somebody could assign costs and go from there. Is that correct?
Gotcha. Yeah. So cost data is always very hard to get. Estimators are always really privy to not share that because it's valuable information they've earned over decades. But if you can get that, you could in the Excel add in cost data of how much the estimate is to install that, or the differential cost from what they are doing to what this is doing, to do a cost benefit analysis or calculating an ROI. So yeah, you could definitely do that.
Great. I don't. Does it have any results we can see?
It should. Yeah. Let's see.
I figured could answer some questions while it's calculating, but
yeah. Any other questions? In general, results are back in 20 minutes or less. I just got the results now. It does take time to analyze all of those things. Yeah. But it's time that you're doing something else, answering questions rather than plugging in numbers.
Yeah. Do you have any other examples you can show, or?
Yeah, I'm pulling up the.
Oh, cool.
Right. All right. The results come in a Excel spreadsheet. First off, it shows you each of the scenarios you ran and each of the design changes and whether or not that design change is present in that scenario. It also includes the results of the base project, so you can see how the homes perform without or as is without any design changes applied. And then the results, admittedly, it's a little kind of raw results, but that's what we found people want. Is just the raw results, and they can go and analyze it however they wish. The really cool thing here is, I'm going to hide this quick, is so for her Energy Star, actually do that one. We have a whole bunch of data here. We have Energy Star version 3.1 compliance, so pass fail, 0 means fail, 1 means pass. We have the same thing for the original plan, which means the base project did it pass. And then we have this thing called buffer. This is the percent above or below passing this energy model is. So you can see, does this design change improve the buffer from the baseline case? And it's a much more nuanced piece of data than just does it pass or fail, because this shows you, oh, this change like improved my model by this amount. And then you can get like a sense of like, okay, all of these things should be added together, or maybe I should try this different design change on the next run. And so here's the buffer change, by 2.2, which is quite a lot. What people usually do is take this information and put it into a pivot table so they can summarize everything really quickly. Let me show you kind of what that looks like. So we have base projects, expand, collapse entire field, and then let's see what the HERS score is and HERS score change. It says sum, but that doesn't make sense. So we're going to switch it to average. And then we start to see kind of what the impact of each of these design changes was on the HERS index. So for infiltration change, on average, it lowered the HERS index by 0.3 index points. The second one was pretty similar. Mechanical equipment change actually was huge. It reduced the HERS index by almost 8 HERS index points. So this kind of shows you how those design changes are performing. And in our analysis, we use this then to calculate how many additional homes passed Energy Star. And I can add in Energy Star compliance here as well. Right.
Yeah, I mean, there's obviously some questions on how detailed some of this can get. So I don't want to get into the specific questions, but again, ICF versus SIPs using some ICF, using some SIPs, different, we can think of, we just had our good friend, Joe from Building Science Corp on last week talking about multiple different wall assemblies. I mean, how detailed can you get in modeling these kinds of things?
Yeah, so you can model any wall assembly imaginable.
Yeah.
The nuance is that, so like you could model what happens if I change it from a 2x4 stud wall to a SIP. No problem. The nuance is that kind of again, like coming soon, you will be able to say only change walls that are in this particular location. Mm-hmm. Right now, it's change all of the walls, which is usually pretty good. And gives you the directionality and the order of magnitude of improvement. But more precise, you would say only change the exterior walls. Mm-hmm. For us, most of the homes, most of our users are single family homes. So like all walls are pretty much similar, but from multifamily setting, being able to say, leave the adiabatic walls by themselves and just change the exterior wall is a pretty big improvement. It's coming soon. So that's kind of a nuance. The other nuance would be, if you want to just say, what happens if I add R5 continuous insulation? We don't have the ability yet to just say add R5. You'd have to say replace whatever wall is there and add in a wall that is 2x4 R13 plus R5, where there's a little bit of uncertainty there, because if you're modeling, if you're analyzing 50 homes, what if one already is R15 and the other one's R13, and then you're switching both of those to R13 plus R5? That one that's R15 will kind of have a different result, because that R15 wall is about the same as an R13 plus R5.
Got it. And just for clarity for everybody, for those, again, with compliance with LEED, by meeting Energy Star 3.1 within this tool, you are on your way to complying with LEED. And then you want to run your HERS modeling to get your points. And then if you're doing 45L DOE Zero Energy Ready, typically that will garner all of your energy points within LEED and air quality if you're following Indoor Air Plus. So just to give you some context on when you're doing this modeling, because I didn't see a specific LEED model in there, but that, that makes sense because there's not like a LEED standard, right? It just gives you points. So yeah. Just real quick, before we get into some of those other questions, I know you need to get going. For those of you who want to rewatch this session or share it with a friend or help us spread the word about it, posting it on social media, go to our YouTube channel, hit subscribe. You'll get an instant update when it's out in the next couple days. For those looking for your continuing ed, watching this in the future, not right now, on demand, head over to the quiz, get an 80% passing rate, and you will receive your certificate. For those of you here live today and you've been here for the entire session, you are approved, and so you should receive your certificates from certs@gutenbergcerts.com. Make sure you mark them as safe. And as always, we need to say a huge thanks to our top tier sponsors, especially our platinum ones, Mitsubishi, Rheem, April Air, all of our board of directors, our volunteers, our executive director, Jose Reina, and our nearly 300 members. Thanks to them and all their support to allow us to do what we do. So, David, you and I were talking before this session, so I'll kind of shorten the conversation here a little bit, and I appreciated the conversation there in that, a lot of times the energy raters, they're out in the field, they're doing their rating, a lot of times they'll get a preliminary plan, they'll produce a quick plan review, see where the project's at. That's usually what they do. And then they're out doing the pre-drywall and the final. And that's where you want raters, right? They're doing that job. That's what they're doing. But, a lot of times people want this scenario modeling to make this informed decision. And I think, you made a really great point when we were talking about, making sure the raters, and in all cases, are getting paid for that time. And maybe you as a rater, if you're a rater listening, put a pricing together for this kind of thing to help the architects and designers and builders out. But let's say an architect, we've got a lot of savvy architect members who kind of want to start this out on themselves before bringing in the rater. What are your thoughts on them being able to access a tool like this and use it? What kind of insight can you give us there?
Yeah, definitely a architect or HVAC designer could use this to do the preliminary work. One thing is there are specific kind of ResNet standards on how a home is modeled for a ResNet HERS rating that is important to do, because that's ultimately kind of the standard way to get it done. But that's not unlearnable. Many people have learned how to do that. So I would caution about that. But other than that, this is a great tool to be able to do iterative design work on energy efficiency of homes, because it automates iteration. And it's also a good tool for value engineering exercises. if you're in a design review meeting, because you can, very quickly look at every single unit type in your portfolio for a particular builder. And yeah, there's no reason an architect or HVAC designer couldn't use this in that manner.
Is it what you produce exportable anyway to the raters doing the HERS rating, or are they really kind of maybe just getting the raw data out of it and then rebuilding it to do the HERS rating?
Yeah, the sharing capabilities in Ecotrope for energy models are largely tied to organizational frameworks, where as long as you're in the same organization, you can share work between anybody very easily. But once you're outside of the organization, our paradigm is one organization's work is one organization's work. So it's not as streamlined to say, hand off an energy model from an architect to a rater if those people aren't in the same organization. It's not impossible, but it's just not as streamlined.
What was the other question I had here? Well, there's a lot of great questions, and I know we have limited time, so we're gonna definitely get those over to you to be able to see if you can follow up and answer them. And I guess just to be clear, this type of iterative rating is, and you kind of mentioned it, but just to be clear, for single family, for multifamily. And then, like you said, there might be some challenges with different wall systems for renovations, but it could be used for all those different types, right?
Yeah, definitely.
Yeah, great. Well, I guess on that note, David, where can people go to learn more, get in touch with you, or maybe figure out how they can access the tool?
Yeah, please visit ecotrope.com /scenario modeling, or just ecotrope.com. You can find it there. Or email me at that email address on the screen, and happy to help you out with any questions.
Thank you so much, David. We really appreciate your time and Ecotrope's time and doing this great work, and we hope to have you back for more conversations throughout this year and in the future. Take care, be well, stay safe. We'll catch the rest of you next week. Goodbye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.